Okay, our potential energy diagrams, page 4 of our kinetics note packet. You'll notice that we're still in the kinetics unit right up here. Potential energy diagrams are exactly that. It is a diagram. We're going to use a graph that shows what happens to the potential energy as a reaction goes from start to finish. There's a basic order for all potential energy diagrams. All reactions start with the reactants, so the potential energy starts at the heat of reactants level. Activation energy must be added to the reactants to get the reaction to start. We can't just go up a hill without putting some energy in. This represents the energy needed to have the effect of collisions. And our activated complex is an intermediate step. Activated complex is very temporary and breaks down to form the products. This is a very simple, but we have many steps that occur. So what we're going to be looking at, for reactions to occur, the reactants must have sufficient energy to collide effectively. As the reactants approach each other, kinetic energy is converted into potential energy. Let's put a star there. So we've got two different kinds of potential energy diagrams that you see here. I'm going to raise this up just a little bit. We have an exothermic and an endothermic. Exothermic meaning we're starting with a high energy, end with a low energy. Start with higher, we're going to go potential energy than ending. So we're starting with a higher potential energy than we're ending with. With an endothermic, it's the opposite. We're starting with lower potential energy than ending. So we've got different parts here. Our activated complex is right at the very top. Both of them. It doesn't matter. Activated complex is at the very, very top here. Okay, so here we're starting with the reactants. Here are our products. Same down here. Here are reactants. Here are our products. This part, to make it up the hill, is our activation energy. Activation energy in this case is represented by letter B. Here it's much bigger.
Attention all seniors.
No, there's announcements. Activation energy. So we're going to be taking a look at a lot of this through the next week.